Hello friends, greetings of the day. So today we are going to understand concept of electrical impedance, which is one of the basic and fundamental concepts in field of electrical engineering, and also for some general knowledge and for courses, undergraduate courses, we need to understand fundamentals of engineering, and out of which this impedance is one of the basic and most important part. So I wish you should see this video till the end. It will be maximum for 15 minutes and understand thoroughly the concept of electrical impedance. Now let's start. Resistance, inductance and capacitance are the three main and most important parameters in electrical engineering. And every component, every electrical device, right from mobile phone up to transmission and distribution lines up to generators, every electrical device is a combination of these three parameters, that is resistance, inductance and capacitance. All of us know resistance is opposition to flow of current. Inductance is a property of coil which tries to keep current constant, and capacitor tries to keep voltage constant. So resistance is opposition to flow of current, which is having unit of ohm, and inductance for AC and capacitance also in case of AC appears as a reactance. So reactances are of two types. First is inductive reactance, which is opposition to change in flow of current through component, and capacitive reactance is opposition to change in voltage. So in case of DC, we don't take into consideration effect of inductances and capacitances, since for DC as a frequency is 0, inductive reactance and capacitive reactances are 0. So by Ohm's law we only write V is equal to IR, and we only take into consideration the resistance of element. Now further, as topic is impedance, we need to understand what is impedance. So impedance is effective resistance of electrical circuit when you are having alternating current. So it is combination of resistance and reactance of circuit. Further, impedance mathematically can be given as Z is equal to R plus J XL minus XC, where XL is inductive reactance and XC is capacitive reactance. In other way around, you can say Z is equal to R plus JX, where X is equal to XL minus XC. Now what is XL and what is XC? XL is inductive reactance, which is given by omega L, where omega is angular velocity and it is equal to 2 pi f. So XL is inductive reactance, that is 2 pi fL, and XC is a capacitive reactance, that is 1 upon omega c, that is 1 upon 2 pi fc. Now as definition is saying, it is component effective resistance of electrical circuit or component to alternating current, because when current is DC, XL and XC are neglected since frequency of supply is 0. As XL and XC both are dependent on frequency, when your circuit is having AC supply, we need to take into consideration effects, and which are called as reactances. So for DC circuit, impedance is only resistance, whereas for AC circuit, impedance is combination of resistance and reactance, which is having equation Z is equal to R plus J XL minus XC. Now as I earlier said, every electrical device is combination of either of these three elements, that is resistance, inductance and capacitance. So now we need to understand different types of electrical circuits. But before that, let's understand impedance triangle. So now as per equation of impedance equation is a complex number or complex parameter. So for complex parameter, the triangle, as you can see, along x-axis there is resistance, perpendicular component is reactance, and hypotenuse is impedance. An angle made by impedance with resistance is called as phase angle phi, and cosine of this phase angle phi is called as power factor. So overall circuit operation is totally dependent on quantities, resistance, inductive reactance and capacitive reactance. Because if inductive reactance and capacitive reactance are absent, Z will become equal to R. And if there are few values of XL and XC, then variation in those values will affect your impedance, and hence cumulatively it will affect the current. Now let's understand types of electrical circuits, impedances and their current equations. From basics we know Z is equal to R plus J XL minus XC. Fundamental equation of voltage for sinusoidal, it is V is equal to Vm sin omega t, and current in case of AC circuit is voltage by impedance. In case of DC it is voltage by resistance. Now let's understand firstly purely resistive circuit. So we are applying V is equal to Vm sin of omega t along pure resistance of R ohm. So in this case, as inductance and capacitance are absent, impedance will become equal to resistance. So its polar form Z will be equal to R angle 0. So in this case, current and voltage will remain in phase. Always remember, because as reactive part is 0, impedance is equal to resistance. So if we take ratio of voltage by impedance, that will be Vm angle 0 divided by R angle 0. So it will be only Im angle 0. So Im angle 0 in a fundamental way, it is I is equal to Im sin omega t. So as voltage equation is V is equal to Vm sin omega t, and current equation is I is equal to Im sin omega t, phase angle phi is 0. That means current and voltage remain in phase. And such case is only applicable to incandescent bulb. Incandescent bulb is example of purely resistive circuit. Next is purely inductive circuit, which is practically impossible, because even though you are having a coil of n number of turns, still that coil is having some minute amount of resistance. But ideally, in case of purely inductive circuit, as resistance and capacitance are absent, we can write impedance is equal to 0 plus jXL, and if you further write in a polar form, it will get Z is equal to XL angle 90. So when impedance is making angle of 90, automatically when you calculate current, as current is ratio of voltage by impedance, and in case of division we subtract numerator angle from denominator angle, so current equation is going to become Vm angle 0 divided by XL angle 90. So further your equation of current will be I is equal to Im angle minus 90. That means current lags behind voltage by 90 degree for purely inductive circuit. Next is purely capacitive circuit. For purely capacitive circuit as shown in figure, we are applying source of voltage V is equal to Vm sin omega t across pure capacitor. Now when your circuit is purely capacitive, resistance and inductance are 0. So impedance equation Z will become 0 minus jXc. In polar form it will be Xc angle minus 90, and hence current will have opposite angle to that of impedance, that is Im angle plus 90. So for purely capacitive circuit, current leads voltage by 90. So inductance and capacitance are completely counterbalancing each other. For purely inductive circuit, current lags voltage by 90, whereas for purely capacitive circuit, current leads voltage by 90. And this is what is basic behind power factor correction. For correcting power factors, we connect capacitor banks in shunt, because inductor causes lagging in power factor, whereas capacitor causes leading in power factor. So cumulative effect is we try to make power factor to be unity. Next is combination of R and L, that is RL series circuit. So impedance will become R plus J XL, and hence in polar form it will be Z equal to mod Z angle phi. So current will lag behind voltage by angle phi. Now here angle phi is not exactly 90, because for pure inductor it is 90, but when we are inserting resistor in series with inductor, angle will be less than 90, and hence for RL series circuit, current lags behind voltage by angle phi which will be less than 90. For RC series circuit, it is opposite to that of RL circuit. For RC series circuit, impedance will have parameters R and XC. XL will be 0. So Z is equal to R minus JXC. So impedance will have angle of minus phi, and hence current will lead voltage by angle phi, which will be less than 90. Okay, so for RL series circuit, current lags voltage by 90. For RC series circuit, current leads voltage by 90. So we have understood till now 5 kinds of circuit: purely resistive, purely inductive, purely capacitive, RL and RC. Now let's understand RLC series circuit. So we are considering all the 3 components connected in series across source of voltage V. So in this case what will happen? we need to take into consideration the three conditions. XL greater than XC, then in that case reactive part will be positive, reactance part. When XL is less than XC, reactance part will be negative, and when XL becomes equal to XC, your reactance part will have value equal to 0. So in this case we need to remember the basic fundamental equation of impedance, Z is equal to R plus J XL minus XC, and we need to just substitute these three conditions to know operation of circuit. When XL is greater than XC, equation will be similar to that of RL series circuit, because inductive reactance will dominate capacitive reactance and current will lag behind voltage by angle phi. When XL is less than XC, capacitive reactance will dominate and hence current will lead voltage by angle phi. And when XL becomes equal to XC, reactive part will cancel out and impedance will be equal to resistance, and hence circuit will behave similar to purely resistive circuit, and hence equation of current will be I is equal to Im sin omega t. Okay, so this is very basic and fundamental part which we have discussed today. We have discussed overall 6 types of circuit: purely resistive, purely inductive, purely capacitive, further RL, RC and RLC type of circuit. Now this analysis can be also done for parallel AC circuits, but more stress is given on series AC circuit, and more importantly resonance condition. Resonance condition is a condition at which RLC series circuit operates at unity power factor. Why unity power factor? Because phase angle phi is 0. So current and voltage remain in phase. Okay. So to sum up, we'll again revise concept of impedance. Impedance is combination of resistance and reactance. There are 2 types of reactances: inductive reactance and capacitive reactance. Inductive reactance is directly proportional to frequency, whereas capacitive reactance is inversely proportional to frequency. So if you increase the frequency, inductive reactance will increase, but capacitive reactance will reduce. Okay, and every electrical device, its analysis is to be done by taking into consideration its impedance. So understanding of impedance is very important. So impedance, 3 parameters are XL and XC, and as per presence of the parameter there are different types of circuits. Purely resistive, current remains in phase with voltage. Purely inductive, current lags behind voltage by 90. Purely capacitive, current leads voltage by 90. For RL, current lags voltage. For RC, current leads voltage. And for RLC, as per the condition, impedance parameter varies and hence current varies. So I hope you have understood the concept of impedance. Please let me know if you are having any suggestions regarding preparation of videos for understanding any other concepts. Kindly share this with your friends so that they will get benefited by understanding basic concepts of electrical engineering. You can also follow me on Instagram or Facebook. For any doubts, feel free to contact anytime, and also make sure you keep your basics very clear so that it will benefit you to crack government examinations also. Thank you. Namaste.